This video is going to go through the opener for the notes for 11.3, the volume of pyramids and cones. If you have not already, pause the video and take a moment to try each part. Okay, so the first problem is asking the distance between 2 points. So I'm going to make use of the distance formula. Part of the way I know this, the problem itself talks about the distance between the points. So, my distance formula is distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And the subscripts of 2 and 1 refer to the point. So I'm going to label the point negative 4, 7 as x1, y1. That's the x coordinate of the first point, y coordinate of the first point. And the second point, 6, negative 1, x coordinate of the second point, y coordinate of the second point. So, plugging in. So, x2, 6 minus, and be careful here, it's minus a negative 4 quantity squared. So I put the negative 4 in parentheses. So you see the minus a negative 4 plus, now this is y2, so it's negative 1 minus y1, in this case is 7 minus a 7 quantity squared. Distance equals the square root of 6 minus a negative 4 is the same as 6 plus 4. So that becomes a 10 squared plus negative 1 minus 7 is a negative 8 quantity squared. Notice I have the parentheses around the negative 8. So now the distance is equal to the square root of 100 plus 64. Remember, negative 8 squared is negative 8 times negative 8, which is 64. And that's the square root of 164. So now I'm just going to grab my calculator. And by the way, if you do not have a calculator at home, you can still go to school and get a calculator. My square root button on this calculator is above the x squared in blue. On the scientific calculators it is also there, but that calculator does not project as well. So I want the square root button. Now on the scientific calculators it will usually give you automatically an open parentheses, and I'm going to enter 164. Close my parentheses, and I'm going to get about 12.81. So I'm going to do D is about equal to 12.81. Okay. So now the second question. Write the equation of a circle with center 5, negative 4 and radius of 8. So the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared, where the center is hk and the radius is r. So I'm going to label my center as h and k, and I'm going to label my radius given to me as r. So h is 5. So I'm going to x minus my h right here is 5. Minus 5 quantity squared plus my k is negative 4. So I want y minus a negative 4. Y minus a negative 4 quantity squared equals, I'm going to take the radius I was given 8 and square it. So now this doesn't simplify at all, so I'm going to leave it as x minus 5 quantity squared plus y minus a negative 4. This was similar to what we did over here. That's y plus 4 quantity squared equals 8 squared is 64. And, oops, I should have boxed this. That's the distance. Here's the equation of the circle. And then lastly, we got to find the missing side lengths. Leave your answer as a radical in simplest form. So, this is a triangle. We're given the right angle. We're given the 45 degrees. This is a 45, 45, 90 triangle. Now, one thing here, because I know some of you asked why not use the Pythagorean theorem, we only know one side length. Now, something that is interesting, because this is also 45 degrees, we could say, oh, it's isosceles, and you will get both this side is 8, and this is called a leg, and the legs are congruent because it is an isosceles triangle. This is the converse of the base angles theorem. Since I have two congruent base angles, the sides opposite them are congruent. So I will get y is equal to 8 because it is an isosceles right triangle. And then x is the hypotenuse. So now there's a shortcut with this. We could now use the Pythagorean theorem, but these types of triangles are often enough where there is a shortcut, and the shortcut says that the hypotenuse is equal to the leg times the square root of 2. The hypotenuse here is x. The length of the leg is 8 square root of 2. If you use the Pythagorean theorem, you would have obtained the exact same answer, except having it multiplied out. Because you would have had, I'll just show it in my calculator, you would have done 8 squared, 64 plus 64, and gotten 128, and you would do the square root of 128. And 8 square root of 2, which this is the way it wants the answer for the x. But that is approximately equal to 11.31. Now, why does this become important? Because these types of triangles, 45, 45, 90 triangles, come up when you have squares. So if this were a square and the side length was 8, you get a 45, 45, 90 triangle when you draw in the diagonal. That diagonal is now the hypotenuse. So squares were an often common enough shape where they have lots of information about this shape and about these distances. And this was discovered to be 8 square root of 2. If you do recall from Algebra 1, when we did this on the calculator, we got the square root of 128 with the Pythagorean theorem. If you recall from Algebra 1, you could separate 128 into 64 times 2, and then you could break up the square root. And that's kind of where all of that came from. So, but this is the rules you need to know is the legs are congruent and the hypotenuse is equal to the leg times the square root of 2. Okay, I hope you are all doing well during shelter in place.